Evening guys, bit of a different video here compared to normal. Probably not massively interesting for existing subscribers, but hopefully helpful for anyone else looking to do the same thing or just looking for some information. This is the first one that I've done, so we'll see what problems I run into and obviously explain them as we come into them. So these days on the farm, certainly in more modern times, the majority of farming now would have some form of GPS guidance in their tractor. So I use a piece of open source software called AgOpenGPS for my tractor guidance. So at the minute I've just got basic guidance, which basically means it tells me where to drive, but I still have to turn the steering wheel and drive the tractor. So auto steer, but yeah, essentially instead of you driving where it tells you to, you just press steer and the tractor does it by itself. So the way we're going to hopefully do this is hydraulically. There's two ways you can go about it really. You can either have a steering motor, which essentially bolts next to the steering wheel and just turns the steering wheel, so you don't really have to interfere with the tractor at all. I'd like to try and integrate this completely hydraulically, so it's completely seamless in the background, nothing in the cab. So what we're looking to do here is assemble a circuit board which will basically house the main components of the auto steer system. Basically it's based on an Arduino, which is what the computer talks to. And then the idea of the board is to try and put all the other components that we need, or the other main components I should say, all on one board, so you don't have a load of little circuit boards flapping around in the wind, damaging themselves in the tractor. So you can see I've got a stack of circuit boards here. So this is based on the PCB version 2. So you can find the diagrams for this exact circuit board. It's all on the GitHub page for AgOpenGPS. Okay, so this is all going to be pretty obvious, but I'm just going to go through it anyway. Just to demonstrate where you can get the information from. So hit up the main AgOpenGPS website. If you scroll down, there's a link then to take you into the GitHub page. So then basically, probably the majority of the time if you're running Windows, you're just going to come in and download the current version in MSI format. That will basically install the application on your computer, and it will then also dump a folder on your desktop which contains the information we're going to be looking at in a minute. I'm actually on macOS at the moment, so that's not going to work. So we'll just come back and we'll just download the stuff directly. So download zip. Where do I want to save it? On my desktop for a minute. Okay, save. Wait for that to download. Okay, so we've got that on the desktop now. I'm just going to move that out of the way. So this is what we've just downloaded. So we'll just extract that one. Okay, just this folder here. So come into the folder that you've just downloaded. The two things that are going to be of concern at this point is your Arduino code and the PCB. So inside the PCB folder and then the auto steer folder, this is where you can pretty much find out everything you need to know regarding what you need and which bits and where they go. So you've got a useful PDF there of the circuit schematic, which is quite handy actually, just to have a look at to figure out, so you know yourself how stuff works. Obviously you've got the Arduino there in the middle, and then all the various components and how they're connected up around the outside. So that's quite handy. It might be worth printing that out if you find that useful. The other critical thing, which obviously as I'm going through it, I'll be referring to the parts list file. That's basically every component on the board as they're labelled on the board. So down the left hand side here, C1, 2, 3, 4, that's all your capacitors, diodes, voltage regulators there, the LED and resistors, and some other bit of the optocouplers there in the middle. So you can basically refer to this file if you don't know what something is. So for example, capacitor 2 is one of the 0.1 microfarad capacitors. Then you've got the thousands and the 3 amp diode, etc. So you can use this file to basically locate which pieces go where. So that's super useful. The PCBs themselves, so if you use a company online which are able to generate the PCBs from file, the file you're going to need generally is this zip file here, the Gerber files. It's super easy to do that. Just upload the file, it will pop up on the website, and you can basically order it. There's a few things you can choose if you want to specifically change anything, but other than that it's pretty much plug and play. Once you've got the PCBs in your hand and you've ordered up all the bits, you can also, I should also mention, you can use the parts list in here. If you use like a company like DigiKey or whatever, you can actually upload that file to the website and it will actually generate a list of all the parts you require.
all for you, which you can then scroll down through and manually delete bits and pieces that you don't need, because it will order some extra bits that you don't need. And you can also check the stock of the items. There's quite a few items I found were out of stock and with a long lead time. So if they aren't in stock, you can just find them elsewhere. There's a few bits and pieces I just sourced from other places, just because it meant it would all be here a lot faster. It's all basic components, so you can pretty much pick them up at any electronics kind of outlet, really. But yeah, that should be all you need to know.
So as I was just saying, you can actually use the Gerber files in that directory to create this board exactly as you see it here. A company like JLC PCB, you can basically send them the file, they'll manufacture and even test the board for you if you want, and then post them to you. It's super simple. It takes literally 10 minutes and the delivery time is pretty good. So as you can also see on the table, we've got an array of other bits and pieces. Again, all of the pieces you need to put this board together in its most basic form are listed in that directory like I showed you a minute ago. There are some components that you don't need. It kind of depends on your setup in your tractor and what supporting hardware you're using. Either you're using steering motor, hydraulic valves, what you're using for your roll correction and all that sort of thing. So you do need to go down the list. I mean, you could just order everything and you've got the lot, but you will end up with some bits that you don't need if you do that. So hopefully if you watch this video, you can kind of see what I'm using and what you don't need. I'll try and explain what the different things are for. So I'll just really quickly whip through here now. So obviously that's the PCB itself. It's just a normal two-sided board. Everything is actually labelled on the board, so hopefully you can see it. I'm kind of the wrong side of the camera here. Each individual component, generally, unless it's really obvious, is labelled. All the resistors and the capacitors are labelled R or C and then a number. These correlate to the numbers that you'll see in that text file in the PCB directory. So if you're not quite sure what value resistor or capacitor go there, look at the file and they'll match up. So that's pretty impossible to get wrong. There's a couple of diodes as well. They're also labelled D1234, etc. Again, labelled in that folder. So we've got the PCBs here. So the heart of it is obviously your Arduino, which is a nano. So that's the piece on the top there. I've actually got it connected to an Ethernet shield there. So it depends on how you want to connect to, if you need an Ethernet shield. If you're doing it over serial or USB, obviously you don't, which is how the majority of people are doing it. I'm actually hoping to connect this over a UDP, so over a Ethernet cable, which is what the shield's for. So you've got the Arduino Nano, that's going to go in the middle. We've got a bunch of headers in different sizes, so that's what things like the Arduino etc. is going to plug into. So that'll be on all the long strips you see. We've got some screw terminal connections, various sizes for power in, out, motor drivers and that sort of wheel angle sensor, that sort of stuff. We've got a bunch of capacitors here, some different values. Again, you'll see which ones you need based on the text file and the holes in the board. We've got a bunch of resistors, a couple of different values, and some diodes, smaller diodes underneath, and there's a couple of big diodes in the box over here, in the bag over here, sorry. A relay holder, that's for your main power to switch the whole system on and off. A couple of LEDs and some headers the other way around there to go on the board. So that's pretty much all the main bits and pieces you need to put this together. So really it's just a case of starting wherever you like and just soldering them on one at a time. So I think we'll start with something nice and simple, this relay holder, which is obviously going to sit on the board. It's really obvious, you can't go wrong, so it's going to go in the hole that's marked relay. Obviously sitting there, flip the board upside down, solder your 5 contacts and then move on to the next thing. So just put a bit of heat on the pin with the iron. A bit of solder. Just so you can see there. So just putting some resistors on the board now. So we found anywhere where it says R as a resistor, so R19, you look on the parts list, that is a 1K resistor. So we've just got one out of the box now, they normally come in little strips like that. One thing to note with resistors, they're not polarity influenced. It doesn't make any difference which way around you put it, so you just fit it either way around. So we want to just bend the terminals down and slide it through the board, just down so it's flush with the top of the PCB. Turn it upside down. If you just put a little bit of bend on the legs, it won't try to fall out then. Bend it over and just put a blob of solder on each one. By the way, you will notice this soldering iron is absolute trash. I would recommend buying a decent fine tipped soldering iron for this type of job. Luckily this board doesn't have a lot of super small stuff, so you can get away with your agricultural spec soldering iron like this one, but it's not ideal by any means. But it gets the job done. And you can just use a pair of snips to cut the legs off again afterwards. Right, that's all the 1K resistors done. So I kind of just picked a component and then did all of that component. So now I'm going to move on to the 330 ohm resistors. Again, these are all labelled on the text document, so you haven't got to worry. Same thing, exactly the same really. Resistor 1, which is 330 ohm, or R1 on the PCB. You'll kind of find you know you've got enough heat. You'll see the solder just sort of sink down onto the board or into the hole. It will sort of sit on the surface and then just drop. That's when you can sort of take the iron off. That's when you've got enough heat going on. Right, that's all the resistors done now. So moving on to the diodes. We've got two different sized diodes. We've got these 1 amp ones and the slightly smaller ones. We'll do the smaller ones first. Only thing that really different with the diodes to resistors is it does matter which way around they go. Obviously the function of a diode is to only let current pass in one direction, so they do need to go the right way. You can see the diode themselves have got a little white strip on them, and the PCB is marked up with the strip. So you can see the PCB is also marked up with a white strip at one end, so just line the two up, and otherwise exactly the same as the resistors. Right, next we got just got one bigger 3 amp diode to fit. It's actually on the output side of the relay, so obviously just protecting that circuit. These are a bit bigger, so that one's going to come up here just on that to the right hand side there, the bottom side on your screen of the. Again, it's the same thing. You've got the white strip on the diode, white strip on the board. So just put the two together, solder in like that, and solder up. Right, now we'll move on to some capacitors. So we've got a couple of different types here. We've got these little 0.1 microfarad ones. And some slightly larger ones here. They're 1000 microfarad. So they're marked C, and then whatever number C1, 2, 3, 4, 5, 6 are all of these 0.1s, and then we've got C20, 21, 22 and 23, which are the larger ones, all marked out on the board. So we'll start with C1, since it's the first one. So these smaller ceramic style capacitors, the polarity of them doesn't matter, so you can put them, same as resistors, they can go either way round. The electrolytic ones, the bigger ones, the big round ones, It does matter on them, so that you'll notice they've got different length legs, also a white stripe on the side of them. The shorter leg on the white stripe is the negative side, which is indicated in the board with the white stripe. So now we'll move on to these larger 1000 microfarad caps. So again, you've got the white stripe and the shorter leg, that's your negative side. And I should have said, you can see on the board the plus sign is marked and also the negative is the white line. So you can't really go too far wrong there. You want to try and keep the bigger caps down as tight on the board as you can. I find if they're not, you'll end up damaging them if they can move around, which you don't want. Just this one. Right, the next two bits we're going to do, well, the next two bits I'm going to do is what's marked up IC2 and IC3. So these are both voltage regulators. So this is basically just step down to 5 volt to give us a 5 volt supply to power the nano and various other circuitry on the board. So again, they're little 3-pin devices. Okay, the markings aren't very clear on these, but you want to basically orientate these regulators so they sit about halfway between the cap and those diodes. If you put them the wrong way round and slot them in, they basically touch the cap. That's the wrong way round. So they need to be the other way round. And then you'll see that they kind of sit halfway in between all the other components. They sort of look happy in that position. So basically, if you look at the PCB, you've got the white line. You want to put the side that the terminals are on closest to that side on the component. Just using the pen there to prop that item in. If I was doing this again, so a little bit of advice, you want to do those before the caps. In fact, you want to do those big tool caps last. Just makes it easier. If you do basically do the short stuff first and the tool stuff last, and everything kind of holds itself in then when you turn it upside down. But if you don't, just use something to prop it in. Not a big problem. Right, we're going to get mounted up some of these screw terminals now. So pretty much the same principle, just stick them through. Obviously they want to go the way that you can access the screw terminal. So we've got some 2-pin ones, some 3-pin ones are the larger ones, and then the smaller ones for the other ones. So that 2-pin one I've just put on, that's your 12 volt in, so that's before the relay, so that's basically where you feed it from. Then we've got 12 volt out, which we can use. That's switched power, so we can power other devices like the motor driver, etc. from that 3-pin terminal. And we've got a pair of ground terminals at the top here, both with 3-pin connectors on them. Right, I sort of sped up past that, so I've got all the sockets mounted now. I'm a little bit short. I am going to want a little 2-pin one, that must be missing off the list. The next thing is going to be all of the headers. So these are pretty self-explanatory. You've got male and female ones. The female ones are actually, if you order the ones off the list, they're already all the right sizes. So you've got the 2 long ones for either side of your Arduino. And then you've got one for the MMA and one for the analog input board. You also need 3 of these. This is for the optocouplers, so you can plug them in and out if you were to kill one. They basically, those little chips essentially, I think, isolate because you've got 3 switches: a work switch, steer switch, and remote. So you can sort of, if you were to accidentally feed those pins with something you aren't meant to, it isn't going to pop the Arduino because this little optocoupler chip, which sockets inside here, protects it. So if you were to pop one of these by using these sockets rather than soldering them directly, you can change them. And then you have some male
same thing, which you can use here and there where you need to be able to make connections.
So these optocouplers, when they get mounted on the board, the orientation obviously does matter on them also. You'll see on the board the diagram of them shows the little dimple in the top. That dimple is also replicated on the mount and also on the component itself. So just make sure you line up all of those dimples and you'll be good there.
Rule of thumb for pretty much all the components is you want to make sure they're sat right down flat on the board before you solder them. If they're up proud from the board, they can move around, and when they move around they'll break, particularly on like the connections and stuff that you're using. It's worth just visually looking at all your connections after, make sure you definitely did get a good connection down to the board, and also that you haven't accidentally bridged anything, which we haven't. Right, so this is our motor controller board, Cytron. Most likely you'll be using one of these. There is some different alternatives, but this is the one that's generally recommended. So mine's turned up, just the board and then the bag with the little cable and the two headers in it. And I think some of them come pre-assembled. So just going to attach the two headers to that board now. We will be using this cable because the board has that plug on it. So we'll use one end of this cable, or we'll use the cable on one end, should I say, and just chop the connector off the other end to enable us to connect that in to the board, if I can get it out the bag. Right, so we've got two connectors there, so obviously they just sit on the end of the board, making sure that you've got it so the wires come out the end, or else, sorry, that way around, or else you're going to have a hard time getting the wires in. So we'll put one there and one there. So this end of the board, we've got power in on the left hand side there, and then your wires going out to either your steering motor or your hydraulic valves on the far side there, and then you've got your pins here that interface with the rest of the board. You can actually see on the bottom of the board those connections are actually marked, so you can't really go too far wrong. So you've got motor on the left there and power on the right. The PCB comes with some pre-drilled holes on the left hand side, which is to mount the Cytron there. Up to you really how you mount it, I guess. I think, well, I've seen lots of little plastic sort of risers, little male to male plastic clip-on things like you see on circuit boards, really just anything to mount that on there. I actually have a box of, I bought a little box of sort of different size spacers and screws and stuff, just a universal kit. It cost literally a couple quid on eBay. As you can see, I bolted them to the board, so now I should be able to just bolt the motor controller. So now I should be able to just screw the motor controller down on top of that, and that'll all be held nice and secure. I think the aim of the game with anything automotive or in the tractor is to keep everything secure so it isn't moving around, because moving around and vibrations will eventually break things. Right, only thing I'm missing here now, you see I've got one of the optocouplers in, but I haven't got enough sockets yet to be able to finish that. So right now we're going to mount the LED on the board. You'll notice the LEDs have got two legs on them. One is slightly longer than the other one. The slightly longer one is your positive leg. Obviously being a diode, it does matter which way around you put these. So your long leg is the positive side. If you look on the board now, we've got it marked on it's just above those three big caps. So you can see there we marked LED. The positive side is the side towards the resistor, it's fed from there. So you've got your long leg on this side and your short leg on that side. I'll just solder that one in a minute. Lastly, that pretty much just leaves us to slot the Arduino into the board. Obviously it's marked on the board USB. That obviously correlates with a USB port on your Arduino. I've actually got mine with a Ethernet module underneath it because I'm going to actually be connecting with UDP. But if you've just got the Arduino, obviously put the Arduino in first.
one last thing to note is it's marked R8 is a resistor. It's marked down on the text file as being a 0 ohm resistor, so you can just wire a piece of wire between those two pins. I'm actually just going to use one of the legs of a resistor that I cut off, just put that down through, bend it and solder that in there. So you can just see I've soldered in that piece of wire there, which to basically just be a 0 ohm resistor. So now we'll just slot our Arduino and Ethernet shield. This is just a plug-and-play Ethernet shield straight off eBay, which just plugs in between your Arduinos. It's pin to pin, so you haven't really got to mess around with anything. You can also get the modules, like one that I actually already had here, which you have to wire yourself, which is fairly easy to do. But I just thought this here is much tidier. Like, again, a couple of quid on eBay, and it all just slots together like that. The relay is just a normal 5-pin automotive relay, so pretty much anything like you find in cars and stuff. I didn't actually order a new one because I've got hundreds of them here anyway, so that one just slots in there. So then the next thing up is going to be the little analog to digital converter. You don't actually strictly have to use this. You can just use one of your analog ins on your Arduino, I think, it's mainly for your wheel angle sensor. But I believe you get a lot more resolution from the sensor, so a lot higher accuracy if you use that. There's a place marked on the board for it. It's what that header we fitted earlier was for. They're super cheap. Again, on eBay you can find these things for next to nothing. ADS1115, if you just search that you'll find it. Mine's come without the headers. It was supplied with the headers, but they're not soldered. I think some of them come complete. So we're just going to solder these on quickly. Slot that one in. And that then just slots in on your board like so. Also, actually I should have said that before I started, to make sure you have this the right way up before you solder that, because obviously you could put it either way and then your pin orientation would be the opposite way around. So that the way you want it is with the one I've bought with the writing on the top, but basically the ground and the power should be at that side of the board when it's in the board. So we've got our little MMA 8452 chip here, again off eBay. The last little thing we've got to do is just solder on the pins or the headers and get that mounted on the board. One thing I did notice is if you just buy a sort of what's known as an MMA 8452 chip, you may not necessarily find the specific one that you kind of need to slot onto this board. This one here that's on a red board is made by SparkFun, I think. So you need to make sure you do end up with one like that, because you can also get variants of it which use a different pin out and some more pins, which obviously won't fit on the board. You can still kind of technically use it if you mount it externally, but if you want the one that will drop straight in the board, you want this one. So again, it's the same as the analog digital converter. You've got to solder the pins on. Mine actually came with two sets of pins. So you have the conventional straight pins and also a 90-degree set of pins. This is obviously so you can mount that at a different orientation. This is obviously going to be for your roll, so that the board can sense the tractor at an angle. If you look closely at the board, there is two arrows on it. The arrows basically indicate, well, X and Y, or Y and Z, or whatever you want to say, because it's a four-way. It can sense either way, so we're only going to be using one of them. So if you mounted the PCB flat, you'll want to use a different set of headers to if you mount the board upright, because obviously you need this chip to be sitting level or with the axis of with the plane of the tractor, so that this board itself is using one of its axes as the tractor is rolling left to right. So just pay a little bit of attention to how you're planning on mounting this before you actually solder your headers on, because you'll be screwed once you have, really. You'll see on top of the board you've got an X and Y with an arrow pointing in two different directions on the right hand side there. That is the direction of which the sensor is mounted for your roll and the pitch angle. So it depends on how you have got this board mounted in your tractor to which of the headers you want to use to mount this onto the PCB.
So if you've got the PCB mounted flat with the axis of the tractor, then you'll want to mount it with the straight headers, so that this board is level with the axle of the tractor. If you're going to mount the board on its side, you'll need to use a 90-degree one, so that then the board is the opposite way to the PCB, so that then this unit is level with the axis of the tractor. Which way you rotate it, that way doesn't matter. You'll just need to select whether you're using X or Y in the Arduino code. There's a little section at the setup section that you can see to just flip it between one or the other. So it's fairly straightforward. In my case, I'm going to be mounting it level, so we're going to be using the straight connections. Right, that's got that soldered up. So that just mounts down at the bottom of the board there. This is also the same as the other one. You need to have the text up, or if you look at the top, you've got 3.3 volt is that side of the board, and the ground is at that side. And then obviously that then makes it easier because you can see the X and Y labelling and the arrows on top of the board. I've read a few people who think they've been having a little bit of trouble with vibrations. You can see there's a little bit of play in that board. There isn't actually holes drilled in the board, because otherwise we could actually mount that on there. So I don't know if we've got any traces in the way there where we could actually possibly drill some holes. Or failing that, we can use the same system and just a spot of hot glue gun just to stabilise that board so it can't vibrate, because I think some people have been having a little bit of trouble with that. Okay, so that's the PCB pretty much together. I'll just slot a relay in there in a minute. Last little step here, we've got two marked points on the board there, so it says on off. So this is basically where you wire in your power switch for the board. That basically triggers the relay to turn the whole system on and off. So it's up to you really what you do there. I see a lot of people have just soldered wires straight to the board. I think I'm actually going to solder a little block on there so I can attach and detach wires, but it really makes no odds what you do for that one there. So I've got it all together now. Just put it on the bench and hooked up a power supply to it. So I've already uploaded the sketch from the Arduino software on the computer. Set a few settings in there which I'll flick across to in a second. So just basically put 12 volt to our battery connections and ground. We've also got 12 volt out from the relay active side, so the powered on side of the relay, for power for the motor driver board, and also an additional ground for that. Hooked up the output for the motor controller also. Obviously our Ethernet is on. You can see it's flashing away because I've actually got it connected at the moment. Just zeroed out the roll sensor on the bench, and everything seems to be working great.
You can pretty much plug the Arduino into your computer over USB. You might want to just actually try this all out before, just directly with just the Nano, before you do use the board. I know I did just upload the sketch just to make sure things are working. But once you've got it plugged in, you just download the Arduino software. And then if you come into that same folder again, AgOpenGPS, Arduino code, AutoSteer PCB v2, and open the AutoSteer PCB v2, I know. So then stuff we really need to worry about from a setup point of view is on this first little part of the first file there. There's a few settings here we can use to set things up. The only things you really need to worry about at this point, your output here, dependent on what controller you're using. So in our case we're using a Cytron, so it's set to 1. Here's where you choose the analog digital converter. If we're not using one at all, you leave it at 0. We are using one, and we're using it in single input mode, so we're just using a single pot, 0 to 5 volt for our wheel angle. Some of the OEM sensors have twin pots in them for 2 outputs, so you'd have that set to 2. If you need to invert that, input, you can use this setting here to set it to 1. And basically, when you turn right, the output needs to be positive. So if as you're turning right, the output of it's getting lower and lower and going negative, you can invert it there. Again, if you find your steering valves or your steering motor is going the wrong way, so if it should be correcting to the left and it's going right, you can invert it here. Switch your button. That is your auto steer activation button, dependent on if it's a momentary button or an actual on-off switch. In my case, it's an on-off switch, and I leave it at 0. Here's your roll sensor. So we're using an MMA 842, a spark fun. You can see it there. So we'll leave that as 3. Well, I set it as 3 already. Here's the part I was talking about earlier, where you can choose which axis of that board to use. So obviously you need to choose the one that is running in line with the axle of the tractor. So they're marked on the board which one's which, so if it's X or Y you can set them here. And obviously if you've got your board mounted the other way around, don't forget you may need to then use those 90-degree header pins to make sure that that board remains level. If your roll output is doing the wrong thing, the same as your wheel angle sensor, you can invert it here. When it's rolling to the right, it should go positive. So if it goes negative, you need to invert it. Tells you all this in the notes anyway. Here would be if you need to choose between serial or UDP. Probably when you're initially setting up, you'll be using serial, so leave it at 0. I've already tested it and it's always working, so I've actually set mine up now to be communicating over Ethernet. So I've set it to 1, and your min and max speed to allow auto steer. So once you're happy with everything, you can come up to the sketch menu and hit upload. You can see in the bottom it's compiling and uploading. So now it's basically uploading this onto the Nano. And the minute that it says done uploading, so now it should be uploaded and running. We can actually come across and use the serial monitor, which I've already got open, which then posts an output. So you can see it's found the 8452, and it's just displaying the IP address it's running on. If I just hit the reset header on the board a minute, you'll see it post again. So I've just reset it there now. There we go. So that's the same thing again. So that's obviously the IP address I'm looking for when I'm in the software. So if we just move that out of the way now and come across into AgOpenGPS, which is simulator's just running in the background. So you'd probably be initially setting up your serial port, which is down here. We're not using serial, so it's not appropriate here, but this is where you would choose what COM port you're on. In Windows, you may need to go in the device manager and look for that port, right click properties to discover what COM port is running on, and this is where you would set that. But in my case, we're using UDP, so we'll come into the UDP options. First thing you've got to make sure is turn it on. Tick the box there. This is the IP address of the board, so unless you've touched anything, that will already be correct. And the only other thing is to make sure that your local machine has a static address which is within the same subnet. So probably in your tractor you aren't using that port for anything else anyway, so you can just go ahead and set it at anything really, as long as it's different to that one. Save and then restart AgOpen, because these settings you need to restart the program for. Once we're up and running, we can actually come down and just monitor the output here. So we can see there's some numbers here now, which is good. Obviously, if I was to power down the board, it would not be moving around. So if I lean the board over now, you'll notice the heading here. Sorry, not the heading. The roll sensor is working because we're moving left to right, as is displayed up here. To zero that out, you can come into the heading and roll settings. If you aren't getting that, by the way, you do need to select your roll source, which in this case is obviously the onboard on the PCB. So you just select from auto steer, restart the software if that wasn't already selected, and then you can zero out here, because when it's in the tractor, you should basically want to park on level ground and hit 0, and that will then zero your rollout. I haven't actually done it here, so as an example I'll do it now. So if you hit 0, then sat on the table there, now we've got a 0-degree roll angle, and if I then pick it up and I'll lean it across, you'll see it start to pick up, and then drop it back down, it will head back to 0. So everything seems to be connected and working great. So hopefully that might be a little bit of use to somebody else looking to do the same. Cheers.